Hello and welcome to Algebra 2 Lesson 43. In this video, we're going to learn about factoring trinomials with a leading coefficient that is not 1. And we're going to be using the factoring by grouping method. So in the last lesson, we reviewed how to factor a trinomial with a leading coefficient that is 1. So this is by far the easiest scenario you're going to come across. So I have an example of that. So let's say you had something like x squared plus 5x minus 24. And here you can see the leading coefficient, or the coefficient for the squared variable x, is a 1. Right? If nothing's displayed there, the coefficient is understood to be a 1. So in this particular scenario, it's very easy to factor this into the product of two binomials. I can just set up my parentheses. And I know if I have x squared, the first position here is x. And the first position here is x as well. X times x would give me x squared. Now, the only thing that I really need to figure out is what goes here and here. And to do that, I think about two integers whose sum is 5 and whose product is negative 24. So I could think about the fact that I have a negative 24. A negative product comes from what? It comes from a positive times a negative. So I could just write that one of these is positive and one of these is negative. And I could just think about factors of 24. I've got 1 times 24. I've got 2 times 12. I've got 3 times 8. Now, when I see something that I know in my mind, those two integers, if I play around with the signs, could get me to 5, I just stop, right? 3 and 8, if I play with the signs, will work. If I had a negative 3 and a positive 8, well, negative 3 times positive 8 would give me negative 24. Negative 3 plus 8 would give me positive 5. So I know I want x plus 8, and I want x minus 3. So that's how you go about factoring these easy scenarios. Not a whole lot of work. You just have to go through the factors and figure out what two integers, again, sum to this, the coefficient for the variable that's raised to the first power, and have a product of this, your constant at the end. Now, what we're going to look at today is something that's a little bit more challenging. Okay? What if we have a scenario where the coefficient on the squared variable is not a 1? So in this example, I have 8x squared plus 51x plus 18. So you notice that this is an 8 here. So I can't just go ahead and set this up and say, okay, well, I have x times x. That's no longer going to be the case. So now instead of just having to find 2, I have to find all 4 positions. So how can we do this? Well, there's 2 main methods that are taught in every textbook. One is going to be reversing the FOIL process, which I personally don't like. And the other is going to be a method that relies on factoring by grouping. Now, I like this method. I think it's quicker and more efficient. So I'm going to start by teaching you that in this lesson. And the next lesson, I'm going to cover reverse FOIL. All right. So the first thing you need to understand is that in your textbook, when they're teaching this method, they're always referring to A, B, and C. And you need to know what those are. So generically, when we see a trinomial, we generally see ax squared plus bx plus c. So what does A represent? A represents this. It's the coefficient for the squared variable. Then what does B represent? B represents this. It's the coefficient for the variable raised to the first power. And then what does C represent? C represents this. This is the constant. So if your book says something like, we want to find two integers whose product is AC and whose sum is B, well, I know that a product of AC is what? Well, A is 8 in this case, and C in this case is 18. So I would need to multiply 8 times 18, and that would give me 144. And then a sum of B, well, B is 51. So what I'm going to do here is I'm going to think about some factors of 144. And I could do that with a factor tree, or I can kind of do that by just going through things. It doesn't really matter. Let's just make a factor tree. 144 is what? 12 times 12. Most of us know that. And then 12 is what? It's 4 times 3. We know 3 is prime. And then 4 is 2 times 2. So to go through this, I could think about two integers whose product would be 144 and whose sum would be 51. Okay, well, we could start with 1 times 144. That's obviously not going to work. You can just mark that out. Then you could go on to, let's say, 2 times 72. Again, that's not going to work. Mark that out. Then, is it divisible by 3? Yeah, of course it is. So I could do 3 times 48. Now, let me stop for a second. When you see something like this, you say, okay, well, 3 and 48, if I had 3 plus 48, that would in fact give me 51. So it's just a matter of going through the factors until you get the two integers that you need. So once I know that I need 3 and 48, it's a little bit of a different process from before. Let me kind of erase this. I'm going to say my two integers are positive 3 and positive 48. So for some of you, you'll stop and you'll say, okay, well, I figured it out. This is going to be x plus 3, that quantity times the quantity x plus 48, and I'm done. Well, no, not exactly. Okay? You need to take this information right here and use it to rewrite this polynomial here. Okay? Remember, when we use factoring by grouping, and I'm just going to erase this real quick. When we use factoring by grouping, we are generally factoring a 4-term polynomial. So what I want to do is I just want to make this trinomial into a 4-term polynomial. And the way I'm going to do that is I'm going to rewrite this middle term, this 51x, using these two integers. So I would have 8x squared. I'm going to put plus 48x. Then I'm going to put plus 3x. And then plus 18. So mathematically, have I done anything illegal? No, because 51x is the same as 48x plus 3x. So I've just rewritten this polynomial as a polynomial with 4 terms. Now, once I've done that, what you're going to see is that you can use factoring by grouping now to get this into the product of two binomials. So from the first group, I could pull out an 8x. What would be left is what? You'd have x plus 6. From the second group, I could pull out a 3. What would be left is x plus 6. So I have a common binomial factor of x plus 6. So if I factored that out, what would I have? Well, I'd have x plus 6, that quantity, times what's left? You'd have 8x plus 3. So the quantity x plus 6 times the quantity 8x plus 3. Now, I'll leave it up to you to pause the video and check this using FOIL, but you will in fact get this back, 8x squared plus 51x plus 18. So this is really quite a simple process. Sometimes it will be a little tedious depending on what your integers are that you're trying to find, but it is something that you can go step by step on. All right, let's take a look at another one. So we have 10x squared plus 43x minus 9. Again, just for the first few, I want to just identify things. So this is ax squared plus bx plus c. So a here is 10, b here is 43, and c here is negative 9. Okay, the negative and the 9. That's why I circled it. So if I want two integers whose product, again, the product is AC. So what is A? It's 10. What is C? It's negative 9. So AC would be 10 times negative 9. That's going to be negative 90. And we want a sum of this middle term B. So a sum of 43. All right. In order to figure this out, I think about the factors of 90. Forget about the fact that it's negative 90. Just think about 90 for a second. 90 is pretty easy. I don't need to really make a factor tree. You've got 1 times 90. And again, you've got to flip the signs around and make this work because this is going to be a negative product. But I already know that this won't work out because it's never going to sum to 43 no matter how much I change the signs around. Then the next thing I would say is 2 and 45. So 2 times 45. Well, immediately I've found something that would work. If I did a negative 2 and a positive 45, well, yeah, 45 minus 2 is 43. That's what I'm looking for. And then negative 2 times positive 45 is negative 90. That's what I'm looking for there. So remember, I'm not done once I've figured this out. I've got to use this information to rewrite this middle term. So what I'm going to do is I'm going to say I have 10x squared. I'm going to do minus 2x. then plus 45x, and then minus 9. All right, so once I've rewritten this trinomial as a polynomial with 4 terms, again, I can use factoring by grouping. So let me erase this, and we'll set this up. So from the first group, I could pull out a 2x. So pull out a 2x. I'd be left with 5x minus 1. From the second group, I could pull out a 9. I'd be left with 5x minus 1. So you see I have a common binomial factor of 5x minus 1. And we can just factor that out. So we'd have 5x minus 1, that quantity, times the quantity 2x plus 9. So this is our answer, the quantity 5x minus 1 times the quantity 2x plus 9. All right, let's take a look at another one. So we have 6x squared minus 5x minus 25. So again, let me just label things. So this is ax squared plus bx plus c. This is a, this is b. In this case, the negative and the 5. So I'm going to circle it, so that's clear. And this is c, negative 25, the negative and the 25. So again, if I want two integers whose product is AC, A is 6, C is negative 25. So 6 times negative 25 is going to give me negative 150. And then we want a sum of negative 5. So we think about factors of 150. Forget about the negative for a second. Just think about factors of 150. 150. So you've got 1 times 150. Again, no way you can make the signs work there. Then you'd have 2 times 75. Can't make the signs work there. You would have 3 times 50. That's not going to work. You would have 5 times 30. That's not going to work. You would have 6 times 25. Again, not going to work. Then the next one you come to would be 10 times 15. If you think about this, I can make that work with the signs. If I had a positive 10 and a negative 15, I can make that work. So I'm always mentally kind of saying, okay, well, I know it would work with the product, but can I mess with the signs here and make it work? Well, yeah. If I think about 15 minus 10 in my head, I get positive 5. I know I need a negative 5, but I can just play with the signs and make that work. So that's kind of what I'm doing here. Okay, that's what I'm thinking about. So let me erase this. We've found our two integers. And again, I just want to rewrite this middle term. I want to rewrite negative 5x using these two integers. So I would have 6x squared. I can say plus 10x, so I could say minus 15x. Wouldn't matter. So let's just say plus 10x. And then let's say minus 15x. And then minus 25. So now that I've rewritten this as a 4-term polynomial, I can use factoring by grouping. So from the first group, I could pull out a 2x, and I'd be left with 3x plus 5. From the second group, I would pull out a negative 5, and I'd be left with 3x plus 5. So I have a common binomial factor of 3x plus 5. And of course, I can factor that out. So I'd have 3x plus 5 here, that quantity. And then times what's left, we'd have the quantity 2x minus 5. So your answer for this one would be the quantity 3x plus 5 times the quantity 2x minus 5. All right, for the next problem, I'm going to do something that's a little bit more challenging. A lot of students see these types of problems and they just shut down. And really you shouldn't, because the procedure is the same. It's no more difficult. So let's say you see something like 8x squared minus 26xy plus 20y squared. The first thing is that notice we have an even number here, here, and here. So before I even start, I can pull that out. So just pull out a 2. So pull out a 2, you'd get 4x squared, then minus 13xy, and then plus 10y squared. Now, once that's done, you think about the middle part here. And again, a lot of students freak out because they only have an x normally, or whatever the variable is. Now you have an x and you have a y to deal with. And they're like, what am I going to do? There's two variables. I'm going to tell you what you can do. Don't even think about the second variable. Just do your normal process, and I'll show you how to work that variable in a second. So if I just ignore the fact that I have a y, just kind of line it out for a second. and just say, okay, well, if I had this scenario, 4x squared minus 13x plus 10, what would I do? I would find two integers whose product is what? A times C. Well, A is 4, C is 10. 4 times 10 is 40. And then whose sum is B. B is negative 13. Now, if I expand on this for a second, I bring my y back, really all I'm going to do is say, well, B is now negative 13 times y. It's the coefficient for the x to the first power. So what's multiplying x to the first power? Well, negative 13 is, and also y is. So I can just say this is negative 13y. And then what's my term at the end here? Well, it's 10y squared. So normally I do the coefficient for the squared variable times the term at the end. We can do that again. So 4 times 10y squared would be 40y squared. No more difficult. Okay, you just include the second variable. But you could also just leave it off if you wanted to, and just make sure that you put a y next to the two integers that you come up with. Okay, so let me just say this. Find two integers whose sum is negative 13 and whose product is 40, and attach a y at the end of those two integers. And I'll show you that that works. So for 40, we know we have 1 times 40. That's obviously not going to work. 2 times 20 won't work. Not divisible by 3. 4 times 10 won't work. 5 times 8, we can make that work. If I had a negative 8 and a negative 5, negative 8 times negative 5 is positive 40. Negative 8 plus negative 5 is negative 13. And what I do is just attach a y to the end of each. So negative 8y and then negative 5y. Because negative 8y plus negative 5y is negative 13y. Negative 8y times negative 5y is 40y squared. So it's not any more difficult when you have a second variable. You just kind of throw it in there, right? And it'll work itself out. Really, the only challenging part is finding the two integers. The variable is a breeze. So knowing that this is what I have now, let me kind of erase this. I'm still going to rewrite my middle term. So I'm going to say this is equal to, we'll have 2 times the quantity. You'll have 4x squared. Now the middle term, I have negative 13xy. So I'm going to use these two. I'm going to put minus 8 and then x and then y. And then minus 5 and then x and then y. So basically I just said minus 8xy minus 5xy. We know that would end up being negative 13xy. Then plus, we have our 10y squared. Close the parentheses there. And the process is the same. I'm just factoring by grouping here. So in my first group, I could pull out what? I could pull out a 4x. That would leave me with x minus 2y. In my second group, I could pull out a negative 5y, and that would leave me with x minus 2y. So I have a common binomial factor of x minus 2y, and I'm just going to pull that guy out. So I'll have 2 times the quantity. We'll have x minus 2y, and then times the quantity, 4x minus 5y. All right, let's take a look at another example with two variables involved. So let's say we saw something like 12x squared plus 33xy minus 9y squared. The first thing you'd notice is you could pull a 3 out before you begin. And this is very important to do this because it saves you work in the end. Right? You don't want to end up with additional factoring because you might miss it. Right? So if I pulled a 3 out, I'd have 4x squared plus 11xy minus 3y squared. Another thing that benefits you to pulling this out early is you're going to end up working with smaller numbers. Right? Smaller numbers are just easier to work with. So once I've done that, again, I want to use the same process. Doesn't matter that there's two variables involved. I can label this as A. Okay, so I can say A is 4. I can say B is what? B is a new row. Remember, it's the coefficient for x. So if x is being multiplied by 11 and by y, I could really say that B is 11y. And then C is what? It's this whole thing here. It's this negative 3y squared. So if I want A times C, I would do 4 times negative 3y squared. So AC is negative 12y squared. And then B is 11y. But forget about these variable parts right here, this y squared and this y. Again, if I work out the integers, in other words, two integers whose product is negative 12 and whose sum is 11, I can just tack a y onto the end of each, and I'll have my answer. So if I want two integers whose product is negative 12, I think about 12, I know I can do 1 times 12, and if I play with the signs, if I do positive 12 and negative 1, that would work. So positive 12, again, put a y at the end, and negative 1, again, put a y at the end. That's going to work. Positive 12y minus 1y. If I threw an x in the mix and I sum those two, I get 11xy. I'm going to use that to rewrite my middle term. So I'm going to have 3 times the quantity, 4x squared, and I'll do plus 12. Don't just put plus 12y. Remember, you have an x involved there. So it has to be 12xy, and then minus 1xy, or minus xy, and then minus 3y squared. Let's scroll down and get a little room going. So factoring the inside here by grouping, we have 3 times inside of parentheses. In the first group, I can pull out a 4x. So if I pull that out, I'd have an x plus 3y inside. In the second group, I could pull out a negative y. So I'd be left with x plus 3y inside. And again, I get a common binomial factor of x plus 3y that I can pull out. So I'd have my 3 outside of parentheses, and then I'd have x plus 3y, that quantity, and then times, I'd have 4x minus y, that quantity. So this is my answer. 3 times the quantity x plus 3y times the quantity 4x minus y.